All right, so the session everybody's been waiting for, not because I'm a part of it, but because it's the last one. So we're going to begin the nutrient management session, starting with Bryan Rutter. So introduction on Bryan, and this topic is we were at meetings in Wichita this summer, and I saw the first report that him and Dr. Dorvar Ruiz Diaz did on this soil sampling handling. And so that's also why we had two posters about soil sample bags, soil sampling handling, because of this information they got about how handling soil samples impacted the results. With that, bringing Bryan down. Bryan is a local. He's a Stillwater local, basically. Got his master's under me. He's getting his PhD up in Kansas. Should be finishing soon. So with that, Mr. Rutter.
Okay, is this picking up?
Now you're up.
Okay.
Talk there. Try it again.
Can you guys hear me okay in the back? Okay. All right, so my name...
Stay there.
Okay. I'm going to stay right here. All right, so my name's Bryan Rutter. I'm from Kansas State University. I'll apologize in advance for my purple slides here. And I'm a PhD candidate at KSU, and I also manage the Kansas State Research and Extension Soil Testing Lab. Today I'm just going to be kind of going over some of the results of different experiments that we've been doing to look at sample handling practices and how that can have an impact on the soil test results that we end up getting back from the soil testing lab. Okay, I think I got it. All right, so just a quick outline. I'll just cover some background information a little bit, and then we'll get into some of the lab experiments, look at the results that we've got, and then maybe go over some summary and guideline stuff for recommendations kind of going forward. So just a quick overview of what the soil fertility sampling, what that process kind of looks like if we were to break it up into different pieces. The first step is going to be we need to figure out what information are we after. And then once we know why are we testing the soil, why are we collecting that sample, then we can come up with some sort of plan for getting that. And then once we do the field sampling, then we can bring the sample to the lab, we can get those results back, interpret them, and then make some sort of management action decision. So why am I showing this? Well, the main thing is just we don't get a whole lot of focus placed on this lab analysis part, usually on the farmer side, consulting, extension guys. That's my job. That's where I come in. You guys hand the sample to me, and then it's my problem. So, but anytime we're interpreting a soil test, we need to keep in mind that we have different assumptions that are going into that, whether we think about it or not. And so one of the key assumptions is always going to be, is that sample representative? I'm sure people have heard people harp on that before. What does that mean for a soil sample? That means, is the sample that I have in the back of my truck at the end of the day that I'm handing off to the lab, is that a good representation of what was in the field? And that is, when you're talking about handing in a pound of soil to represent a couple million pounds of soil out in the field, that's a pretty big assumption, right? So we spend a lot of attention, there's a lot of discussion that goes into how do we do that. Typically, that's going to be something like this, where we're talking about, am I collecting a composite sample, a zone sample, a grid soil sample, what sampling depth am I using, how many cores, that's a big one, right? Where are those cores coming from? Are they coming from in the row, between the row? When am I collecting that sample? So what about once we have that sample? We've already gone through and collected it. Now it doesn't matter if it's a composite or a zone or a grid, if it's 0 to 6, if it's 0 to 24, it doesn't matter. Once we have that sample, what do we do with it? How do we handle that sample? And does that have an impact on the soil results? So we're kind of looking at that intermediate step. And I think this is kind of an important thing. And as far as current recommendations go, I haven't really seen anything set in stone as far as different labs go. It's kind of just a common sense thing of get the sample into the lab as quickly as you can, but what happens, Murphy's Law is a real thing, especially in agronomy. What happens if you're not able, you may have every intention of getting to the lab that evening, what happens if you're not able to? What happens if you weren't able to get that sample dropped off? Maybe it takes a while, maybe those storage conditions weren't the best before you got that sample turned in. So those are some of the questions that we were kind of trying to answer with this. And the way we went about getting the information to try to answer those questions is we went out to the farm north of Manhattan, kind of the northeast corner of Kansas, and we collected a big batch of soil, roughly 100 pounds, brought that back to the lab, mixed it up really well. This part's kind of a pain in the neck because you're trying to homogenize a big batch of soil. So we mixed that up really well by hand, ran it through a pretty coarse sieve, about a 1/4 inch, and sieved it, mixed it again, sieved it, mixed it again, sieved it. We did that 3 times. And then we took scoops of that homogenized soil and put that into our soil testing lab bags, the same bags that we would give out to a producer. And we had 3 replications for these different kind of groups or treatments that you kind of think of them as that. We have one scenario, which is here in kind of these green squares. This would be kind of the best case scenario of we went out to the field, we collected the sample, we got it to the lab the same day, within a couple hours actually. And that's the no storage, turned in on day 0, the same day of the sampling. And then we kind of have these 2 other scenarios of something happened, but I was able to at least get my samples in the fridge versus something happened and I didn't get my samples to the lab or into the fridge. And those are the truck bed storage samples. Those basically sat in the back of my pickup for anywhere from 2 days to 14 days after initially collecting that soil sample. And so again, this soil came from kind of the northeast corner of Kansas, pretty standard stuff for this part of the world. Continuous corn, strip till, dry land, not irrigated. We're on a silt loam. The soil was fairly wet when we sampled it. We're at about 19% moisture, gravimetric water content there. So what did we do? Well, we looked at soil pH, buffer pH, phosphorus, potassium, nitrogen, sulfur, the micronutrients, copper, iron, manganese, zinc. We tried to look at just about everything that we would normally have a producer or an extension agent come and talk to us about or a request from the lab. Now there's all sorts of ways that we can analyze this data statistically. I'm trying not to get too bogged down in the statistics here, but I would just like to point out that we basically have comparisons between how the samples were stored, whether they were in the fridge or in the truck, and we can compare that with those samples from the first day. And then we have that change over time component. So we can look at that as well, how the soil test changed over time in these 2 storage areas. And then we kind of have an interaction between those 2 so we can look at the trends, where the trend in the refrigerated samples, was that similar to what was in the truck bed, or is it much different? And I've got a little table here kind of summarizing statistics of that, and basically what we have is we have a big group of soil tests that it didn't really matter whether they were turned in the same day or 2 days from now or a week from now, and then or whether they were in my truck or in the fridge. And that would be soil pH, buffer pH, soil organic matter, anything in this first column here, phosphorus, potassium, and strangely, ammonium didn't change. And then we have a few where they had a trend over time, but it didn't really matter that much whether they were in my truck or in the fridge. And those would be the micronutrient metals, so copper, iron, manganese, zinc. We'll take a look at those here in just a second. But we're going to kind of focus on this last column here with nitrate and sulfur, particularly with nitrate, because that's a case where they changed over time, but the change over time was different whether they were in the fridge or if they were in the back of my truck. All right. Do what? We'll get there here in just a second, but yes, that was in June. Okay, we'll get there here in just a second. We'll look at some of that. So right here, we're going to look at, I think I skipped something here. Okay, so yeah, just a quick look at the micronutrient metals. So these were a statistically significant trend, and for all of them, that trend is slightly downward. Now this kind of comes into play of, is this statistically significant, but is it also agronomically significant? I don't know. The micronutrients get a little tricky trying to interpret those for different crops. The main one that we usually focus on in Kansas would be zinc and maybe iron as well. But as far as the soil test goes, that zinc is going to be one that we get requested more than probably anything else. And we're going from about, so I have the soil test here on the y-axis going up and down. Higher is a higher soil test. Further to the right is farther in time. So those sat in storage longer. And we can see that we started with zinc here on this bottom right panel. We started at about 1.7 part per million. And after 14 days, it had dropped down to about 1.5 part per million. So not a very big change. So I'm not generally too concerned with these. What I think is a little bit more interesting, again, is going to be this third column group here.
Samples are in each?
So each one of these, that's a good question. So each one of these is was run in triplicate. So we have 3 samples for each one. And right now we're just looking at the mean. We'll look at some variability here in just a second. So here we can see kind of some noise in these relationships, but in general I think the trend is pretty clear. This is inorganic nitrogen, so this is ammonium and nitrate. This would be that pool of nitrogen that's considered to be more or less immediately plant available, right? And we can see that those purple points, the distance between them and those gray points is getting bigger over time. And that's telling us that the inorganic nitrogen in the samples that were in my truck, that number is going up over time. And kind of a little bit more noisy with the sulfur, but a similar trend in that the truck bed and the refrigerator samples are there's more of a gap over time with those. So we have something going on there, right? So let's look at the nitrogen in particular. I know we probably have some nitrogen ninjas in the room here, I'm sure. If I'm talking about inorganic nitrogen here, there's nothing magic going on in these samples. That nitrogen's coming from somewhere. And it's coming from that organic pool. So what we're looking at is mineralization of nitrogen. So normally we would say, hey, that's awesome. That's good. I want that in my field. You want it in your field, but you probably don't want it in your soil sample, right? And a similar thing with the sulfur there. Now in terms of kind of going back to that, is this an important thing or not? If I'm working with an initial concentration of 6 part per million for a 24-inch sample, you can see the equation there, part per million times 0.3 times your sampling depth is going to give you your pounds per acre. And so in Kansas, we typically use a 24-inch sample if we can. And so we're looking at roughly around 50 pounds in that profile. Now what is going to be the difference if instead of turning that sample in on the first day, we maybe stepped out a week to that 6 or 8 day time frame and then turned that same sample in from that same field, the same spot in that field. And now, instead of my soil test telling me I have 50 pounds, now it's telling me I have over 100. So to me, that's a pretty big difference, and that's definitely worth keeping in mind. Similar with the sulfur, we're looking at 10 to 20 pound difference there. And this also comes back to that, is it a representative sample or not? The stuff in the fridge, it's not really changing very much over time. It's more or less those gray points there's not really an up or down trend there. They're pretty much just staying the same. That looks pretty good to me. That's kind of what I would hope. But the stuff in the truck, I would say that's no longer a good representation of what I had in my field when I took that sample. So going back to the question of when did this happen? So this was roughly the second week of June in Kansas. And here we're looking at air temperature. So the red line here is really the main one that matters, and that's the air temperature inside the box that I have these samples in the back of my truck. So while it got pretty warm towards the end of the study, I guess. It started off relatively cool, upper 70s, 80s, high temperatures. But even then, inside that sample box, I'm still getting over 100 degrees in my toolbox in my truck. So I thought that was kind of interesting. I didn't expect it to get that warm in there. But so these samples were collected on the 9th of June, the second week of June, and we kept doing this for a couple weeks. So kind of taking a little closer look at the nitrogen, because before we were looking at that total inorganic nitrogen, and now we've got it split up by ammonium versus nitrate. And we can see that most of this change, most of this increase in time, my ammonium is not really changing very much. Most of that is just due to nitrate in the soil, which that's kind of an interesting thing. I was not really expecting that. Anybody have any ideas what might be going on there? So we know that nitrogen it has to be coming from that organic pool. So we're talking about nitrogen mineralization. And one of the first steps of mineralization, when it's coming from that organic pool into nitrate, it has to kind of go through ammonium. To me, what this is showing is that ammonium is converted to nitrate pretty quickly in your sample. Doesn't really have too much to do with this study. I just thought it was kind of an interesting thing there, because as soon as it's just rapid, it's not even showing up on the ammonium. I know that I'm increasing my inorganic nitrogen, but it's only showing up on the nitrate end because it's being converted so quickly. So now, up to this point, as a grad student, we're always told, put error bars, don't ever just show me means. So I've kind of done that intentionally here to highlight this. So I think this is kind of interesting. What's going on here? My gray points, those are the ones that were in the refrigerator. And my error bars for those are really small. You can't see them most of the time. Now the ones that were out in my truck, those error bars are pretty big. So here what we're looking at is the standard deviation with just showing kind of the variability in the nitrate measurement of each one of those 3 samples that was turned in each day. Okay, so it's at those first 3 samples, that nitrate measurement was almost the same for all 3. And in fact, it didn't really matter, as if it came out of the fridge, they all 3 pretty much had the same measurement. Now if they came out of the back of my truck, the spread in that measurement got pretty big. So I think that's pretty interesting to look at. And I think that has some implications for, especially maybe for people doing grid sampling and really doing a lot of soil sampling. Kind of think back to why are you doing that in the first place? If you're trying to look at variability in your field, you definitely don't want to have this situation here. So this figure on the right is basically the same information there. It's just kind of the width of those error bars plotted versus time, so you can see that a little bit easier. So conclusions of the study. Can sample handling practices, can the way that we handle that soil sample, can that impact our soil test results? Yeah, it can, especially for nitrogen, sulfur, some other things as well, but particularly for those 2. The warm storage temps seem to correspond to a pretty large increase in nitrate, especially the longer it sits there, the more mineralization that's happening, the more that change is going to be. The warm temperatures also seem to increase the variability in that nitrate measurement. Not the measurement itself, I guess, but in the amount of nitrogen that's in the sample. So what can we do? Well, this kind of comes back to before. There's not really many changes, I guess. Get the samples to the lab as quick as you can. If Murphy's Law comes up, if something happens, either air dry the samples or get them in the fridge. If you get them in the fridge, based on this, seems like you're doing pretty good. You're probably just fine, especially from the nitrogen perspective. Really not a lot of change going on here. You know, we're looking at 3.5 part per million at the start to 2 weeks later having 3.5 or 4 part per million. So not really changing very much there. So, I don't know how I'm doing on time here, but
You got plenty of time. In fact, we're going to.
did I go too fast?
Yeah.
Okay.
Yeah, Mike, have you thought about taking, instead of just doing it in your pickup, have you thought about taking your samples, say like you took them there in Manhattan,
Mm-hmm.
ship them to Dr. Arnall, he sends you samples, and you guys do cross-testing with other labs about time delay in actual shipping, and see how those differences would be. You know, that way you can actually get actual shipping times.
Sure, yeah.
And for like that.
So, I-
Matter, you know.
Yeah, that's so here what we were trying to kind of do here, I think, was really kind of look at the worst case scenario almost, just to see, because we didn't really know what was going to happen. So we figured if we put them in the truck, we can see how bad it could be.
Right.
So,
You know,
Mike.
say like you get it to your county agent in Colby.
Sure.
oh,
And,
hold on. I'm going to answer your question, Mike.
okay.
So the answer is that will be something Oklahoma State does. Because did you see our posters about that? So our next step is Highland's probably going to have a master's student, and we're going to go and survey our county extension offices and find out what is the sampling, what does the sample happen before it hits the office, and then we're going to send thermometers. We have digital thermometers, and we're going to have county offices drop it in the boxes and see what that time and temperature is from shipping from, say, Canadian County, Texas County, McCurtain County, and see what that is inside the truck to do that. I want to add in, so the K-State is a paper bag with wax or plastic coating, right? Okay, so most of your commercial labs are using that. How many of them just have straight paper? Does everybody basically have a wax or a resin lining in them, or plastic? So we tested Ziploc, swaffle bag, and that paper bag with a plastic lining. Swaffle bags dried out within 2 days, and everything was stable because they're permeable from moisture. Ziploc was horrible. If you put a soil sample in a sealed Ziploc baggie, you've just screwed every organic matter measurement up possible. Don't. The commercial bag with plastic was almost as bad as Ziploc because you're sealing it up and you're not allowing that air to leave and the moisture holds in. And so we found massive ammonium differences. It's a soil type. So both of our labs are going to be looking at multiple soil types, multiple organic matters. We sampled ours in Zhao is in August. Okay, so y'all remember August in Oklahoma? We had to wet our soil so that we could dig our soil. Right, and it's a sandy soil at that, but we still couldn't dig it that wet. We wetted, and we found the nitrate went from basically 8 pounds, so 4 ppm to 40 ppm. So 8 pounds to 90 pounds basically in a 1 week period. That's just nitrate. Ammonium went up about 10%, no, tenfold? Pounds per acre? Okay. Oh, for 4 to 40, sorry, 4 to 40. We still had 3, but
For the profile, or like for the profile? So
that's just a 6-inch sample.
6 inch, okay, yeah,
Yeah, so from 4 pounds at 6 inches to 40 pounds at 6 inches.
yeah.
What's going on with the virus, all this bacteria, you know, when you throw it in the black truck, you get up, it's just accelerated.
Yeah,
Yeah.
all that stuff is temperature and moisture dependent. So as long as, you know, the microbes are doing their thing out in the field, and that's what we want, right? Because that's cycling nutrients from that previous crop residue, from the organic matter. You pull that sample, mix it up in a bucket, put it in a bag, put it in the back of your truck or wherever, they're still doing the same stuff they were doing before, maybe even better if you've just mixed all that and really put a lot more oxygen into that system. Stuff can,
You need to either cool or dry.
yeah.
So how many custom samplers have we had out here? Who's pulled more than one soil core? All right. How often is it maybe a little wet, and by the time you get done with the day, that cardboard box that you're dropping those Midwest labs into is a little soggy? Does that ever happen once? Not this last summer. And then it goes in a truck and FedEx, and it might get there overnight or it might not. Or how many times? So ours was cool. Bryan put his in a toolbox. We put ours in a minivan. Front seat, middle seat, back seat. You can see the difference on each part of the van that was sitting in, because temperature and all that had a difference on it. So the variance in that toolbox is where maybe those samples were sitting inside that toolbox, covered up or something like that. So sample, and so we talked about this, and so PK and stuff, we had a little P, we had a little K. I know not a lot of you use nitrogen. How many of you considered sending samples in for soil health indices? CO2 burst, nitrous, many of those things are influenced by sample handling up to the point. So that's a big thing of what we're trying to understand. And again, if you're doing those samplings and the lab's not running nitrate, you're probably okay.
Yeah.
Don?
If you're going to grow wheat, I mean, you need to have enough time. You need to have enough time to get your lab results back and then do some sort of action, usually, you know. So I would say.
I know 40 years ago, our extension wheat guy in our area said the best time to sample was August.
Yeah, I think it kind of depends on when you're going to plant it. But yeah, I think that's probably okay.
Your biggest fluxes will be pH, nitrogen. So in August, if you sample in August, your residual nitrogen will be low.
Yeah.
Because we've not really started breaking down straw matter. And so you're going to get a higher nitrogen rate recommendation if you sample in August than otherwise. And so that's the deal. John?
I think a lot of these guys send in soil samples in
Mm-hmm.
plant. We obviously know we're doing it 14 and 15, some lot things. How important when it comes to plant tissue is temperature. You can look at the fact.
We're kind of working on starting something with that too, because I've gotten samples that if they come in a Ziploc bag and you open that Ziploc bag, the ammonia will just about knock you on the ground. So it's clearly the moisture and temperature of that is definitely having a big impact.
I ground forage samples in the soil testing lab for 2 years, and I'll tell you, there's a lot of nasty forages that hit that lab to get ground. And I'm not talking just been in a Ziploc baggie for a day. I'm talking been in a Ziploc baggie in a truck for a month. And you got as much mold as you do forage sorghum in there for that analysis.
The issue that I'm having personally is I'll take a 44 cooler truck, have my ice packs in there, but I get this new physics, cold and warm air. I put my first layer of tissue in that cooler, and I put the second layer back in there.
Warmer.
Suddenly they don't ever cool off. And I keep wondering if, like Makita or whoever makes some of those.
I wouldn't.
$400 fridges.
No, I wouldn't do Ziploc baggies. You need a bag that is able to allow that moisture to escape, and that really helps. So again, the Swaffle bags, which is a permeable plastic, I mean, it will drip water out of it. We measured moisture too. So we went every 3 days. He went every 2 because we went out to 30. We want to extend it. By day 6, was that right, Joel? Day 6, the Swaffle bags were dry. Correct? Yeah. The Ziploc bag and the commercial bag with the plastic lining, the Ziploc was a little bit higher. Commercial lab was still just under the Ziploc baggie with the sealed seal. So it's that allowing it to air. We take samples, either put them in a freezer or immediately get them back to the shop and open them up, because we use those paper bags too for our lab. We get it back to the shop, and that day we open it up so that moisture can escape and everything. It's all about moisture retention, allow that moisture to leave. Not on me at this moment. I do not. But soil testing lab down in the basement of Ag Hall has plenty of them. I do not carry them on personally. I do have them in my truck. Huh? No, Ag Hall. It's on Ag Hall in the basement. It's our soil testing lab. County agents have them too. County office will have them. Right, county educators? Everybody's like, yep.
They better, right?
They better. That's kind of why I tell a soil fertility team that didn't have soil bags in their truck one day.
I suppose there's people in this room that do more soil sampling. We provide a check in the Midwest laboratories somewhere between $11,000 and $18,000 a month. And we've seen a dramatic increase in the test results we've gotten back for nitrogen.
Mm-hmm.
And of course, up until the last 45 days, it's just been 100 degrees every day in San Diego. And we do a composite sample, take 25 cores and put it in the bucket. Would you guys suggest from the presentation that you just made that if we put those in a cooler in the field, it would lower our overall nitrogen?
I will. Brian, you want me to, or you want me?
I would say you're going to get probably a more accurate estimate of your actual field nitrogen. So one thing we've seen a lot this year is we had a really dry year in Kansas. Corn, not a very good year for dryland corn. We had a lot of fields, particularly in the western half of the state, that may or may not have been even harvested. And so a lot of people have been going back this fall and kind of doing a profile sample to see what do I have left. They fertilized that corn, but it only 60 bushel corn.
So
what do they have left? And they've seen high profile nitrate.
I've got a blog, and we'll kind of move on from this. I've got a blog out there that explains it. What happened with the drought? We had a lot of evapotranspiration up. We pulled nitrate. We pulled sulfate up. Lack of moisture also shut down organic matter cycles, so we didn't have any of that tie up. So we were seeing nitrate values, I think you'd get a head shake across the room, nitrate values this year up until the point of rainfall was high. We got rainfall, it stayed warm, they're also going to crash because we've had a bunch of organic matter that needed to be bound up that wasn't, because typically if we cut wheat, we're wanting to plant, if we do double crop, we have some kind of moisture, that wheat residue, that wheat root's breaking down, same thing with corn, it's breaking down after corn harvest. There's just no moisture in that soil to do that, and just so much wicking up even under irrigated fields because the evapotranspiration was so high. We've had a significant collection of nitrate and sulfate in the surface 6 to 12. All right, I'm going to move on. Brian will be around. Him and what K-State's doing, great resources. I love working with these teams. If you'll hand off to Dr. Lofton.
Yep.
Yeah, give him a hand. So we only did our work because Dorvar and them did that work and found it so intriguing what they were seeing by those results, and we're going to continue it on and keep running. Yeah. All right, and as we all know, so this is Dr. Lofton, cropping system specialist in the fertility section. I told him to talk to us for 45 minutes about double crop fertility. It ain't going to happen. Hey, Josh, if you're standing down there, don't move because Dave Deacon would like you to stand still.
If I get one of these things on, I gotta make sure not to start yelling at you because that's usually what I do at these presentations. So, yeah. So, Brian asked me, I will say, like 2 weeks ago, to come talk to you guys about a little bit about in the fertility section on some of the work we've done on corn, and he told me to kind of. Well, tell him about some of the nitrogen work you've been doing on double crop corn. And me being an agronomist, I just can't talk about just fertility alone. And I think it's good for us to stop talking about these individual subjects alone, because how many times are you guys only worried about fertility? Nitrogen's the only thing you're going to worry about, right? You don't care about weed management or planting rates or anything like that. It's just, this year I'm going to successfully take over nitrogen, right? No, we don't ever do that. Everything kind of goes within that realm of management and how we do it. And sometimes some of the things that we do within the system greatly change some of the things we think we have a handle on. And I wanted to talk a little bit about the plant population's nitrogen management on corn, We're going to talk first about full season, and then you can thank Brian Vincent in the crowd for us talking about double crop corn. It's one that is kind of gaining a little bit of popularity. We've actually had this presentation or talk about this subject in the South and the Mid-Atlantic, and a lot of folks are kind of starting to get interested. Nobody's kind of willing to pull that trigger yet, but a lot of folks starting to get interested in maybe shifting how they think about corn management. So the question overall comes to kind of, what are we asking? What are we trying to do with looking at these populations and these double crop corn systems? And if you think about some of our corn systems in dryland western Oklahoma, so we're talking about north central to northwestern Oklahoma, so we're not talking about the irrigated panhandle corn today. I would say in most years we're probably not talking about that northeast corn, but in the last couple of years that northeast corn has probably been about as dry as that north central corn has been. So, but what we're talking about is our dryland kind of semi-arid corn systems, mainly in western north central Oklahoma, but just kind of some of those to where the moisture limits our yield potential down a little bit. So my question posed to you is our current plant populations too high for our dryland western corn? Don't give me an agronomist answer. I get to say it depends. You don't get to say it depends. That's my response. But I think you're right, and I think there's some intricacies to there. But what I think we kind of have to make sure that we're not doing is getting into this where we're blocking ourselves with required vegetation. Okay, when I talk about required vegetation, what I'm talking about is as we increase our plant population, each stalk goes out there, has a certain amount of biomass that it's going to have to produce grain. If it produces that biomass, we have to feed it. We have to feed it nutrients, we have to feed it water, we have to keep it going. So as we increase our plant population, what are we doing? We're increasing that required vegetation out there as well. So what I think we need to do is ask ourselves, are we getting too high on that required vegetation? And do we need to adjust some of our plant populations because of it? The other thing we're looking at is a new way we kind of think about an old crop. I work a lot in some of the crops that people say, hey, let's try this. I've done a lot of let's try this. Usually back a couple years ago when Jeff Edwards walked into my door and sat down and said, I need to talk to you about something. It meant that there was something that he needed work on. And oftentimes this was a new crop or something that was coming into the system that somebody said we needed some information on. And this new information often was to fill a challenge that we have in Oklahoma. And I propose the thing is that sometimes we maybe don't need to be looking at new crops, just how we manage our current crops that we already know so much about. So let's think and let's look at corn in this situation and how we can do it and how we can modify how we currently are managing corn to deal with some of the challenges. In this case, we're talking about moisture situation. And we already do this. We look at our soybean systems, our sorghum systems out in western Oklahoma, and we've moved and shifted those plant populations around where we get our most critical growth stages to where we aren't 100 degrees with no outlook of rain. So let's look at that for corn too. So overall, what we're going to do today is talk and look at how we manage a corn crop when moisture is limited. Okay? Overall consensus, what we're going to do. So if I were to say how much moisture does it take to produce a bushel of corn, what would you say? Do not say it depends. Anybody? Nobody wants to take that guess? 10, please leave. 10, that's a fertilist over there. Anybody? Acre inches of water.
18.
Ooh, at least he said something, guys. I like you. Okay, so when we look at moisture, it takes about 11 inches for corn to produce the first bushel of grain. If we are under 11 inches, we probably aren't going to produce that much grain. We're just not going to have it. Now, there is some caveats to that, in that it has to come at the right times. and we have to not be stressed at certain point in times. But as an overall, when we start looking at seed yield, some good data out of Kansas State, 11 inches is kind of right where we start seeing that corn start moving into that bushel of grain. We do this oftentimes when comparing grain sorghum and corn, so showing that at a certain point in time, efficiency of production of corn increases over grain sorghum when we have an irrigation capacity over a certain amount, or we're at a certain amount of moisture during the course of the season. But we do see corn here right at about 11 inches is kind of where we start making seed, and that's kind of how much we need during the course of the year. So on any given year, is 11 inches easy to come by in western Oklahoma? No? Well, I mean, that's overall. If we take a look at our mesonet, and so we have our spring, so Wes, correct me if I'm wrong, spring encapsulates March, April, and May. I think it's March, April, and May, and then summer is June, July, and August, I do believe is what it is. The maps on the left are going to be your precipitation, and the maps on the right are going to be your total ET for tall crop during that period, okay? So during those critical 3 months. And what we see is we're often working on a deficiency most of the year. We're kind of living rainfall to rainfall in some of our dryland systems, especially on a crop like corn that needs such a high starting rate for moisture even to get going, okay? So we are dealing with those situations. So the question then becomes is, what's the best way to overcome this issue? The answer is just put some water on it, right? Irrigation is that number one issue, and we kind of see that in some of our areas that have that potential to put irrigation, that the easiest way to overcome some of that situations is just adding more water to the system. Well, in our dryland systems, we can't necessarily depend on Mother Nature, kind of like what we heard a little bit today. I will say I don't like, Brian, when you invite OU people, because they are filled with nothing but bad news every time they come to this meeting. So. But if you look at the outcome or the outlook in some of our years, we just don't have that. And so we have to shift to some of our things. And in my realm, we'll look at agronomic management. So we could talk no-till, minimum till. I think that's always talked about where moisture savings, just having residue on that surface, minimize evaporation is good. Cultivar selection, I'm sure most of you that live out in dryland territories have dealt or tested some of those Aquamax varieties and seeing how they do, and some like them, some don't. And then the other thing that we're going to talk about is just growing it differently than you've previously grown it, okay? So the thing that we're going to focus on is lowering that population. This is why we asked about the high population is lowering. Who here has heard that in drought years you want to increase plant populations? Anybody heard that? Okay. Well, good. You guys aren't listening to the Midwest folks on YouTube, I guess. So, but that is a thing that is done in certain parts of the Corn Belt. Why? Because most of the time that moisture limitation is short term. And so when a corn plant goes under moisture stress, what does it do? What? There it is. It closes leaves, rolls up those leaves. Well, what happens to the plant physiologically when we roll up leaves? Increasing photosynthetic rate, decreasing photosynthetic rate. We have less photosynthetic rate because we're capturing less the photons, so we produce less. So what's the response to that? Well, if we put more satellite dishes out there, we can capture more rain. Or sorry, we definitely ain't capturing more rain, but we're capturing more sunlight. So when we're talking about short-term drought, like those folks in the Midwest potentially thinks that they experience drought, that is a way that you can do it. But in our part of the world, we aren't necessarily in a drought, but we're in a resource-limited environment. That's kind of how you got to think about it. It's a resource-limited. It's not that we sometimes don't have water. It's that moisture is oftentimes our limiting factor to produce grain. So we can't necessarily just say, hey, we're going to roll up the leaves for a little bit, and then they're going to reopen, so having more plants out there is going to be beneficial. No, most of the time we're at a consistent deficit where we're trying to make up for it. However, what we have to do if we talk about lowering populations, what makes yields? Yeah, just having kernels out in the field. More kernels per square foot equals more yield. That is your secret of the day. If you get more kernels, then you get more yield, okay? So it's a balancing act, is we have to manage stress, but we also can't just go so far one direction to where we just don't have physically enough kernels and enough ears to manage what we can do. So what happens with the lower population? Like I said, I've given this talk a lot of places and talked to a lot of people. Most people are saying, well, are you looking to increase yield? Not necessarily. That isn't oftentimes the number one factor we're going on. We potentially could, but what we're trying to do is just temper out variability. So if we have a higher yield or a higher plant population out there, sometimes we can have really high yield, and some years we have really low yield. Well, most growers that I talk to don't like really, really high years and then really, really low years. They'd rather have a really nice years just across the board. They're okay maybe not hitting that bumper crop one year as long as they don't zero out the next. And that's kind of what we're looking for, less variability, more consistency, and you can see that, and that potential is there. So the question then goes is how low is too low? And what is the best population for corn? What I can do is I can ask that question, let you guys argue, and I can go get a drink here and grab a cup of coffee. Because I think that's one of the most divisive questions you can ask about most systems is what's the best population? But if you guys were working with growers, north central Oklahoma, semi-arid environment, dry land corn, what would you recommend? 14. 21?
Down south.
Brian, I haven't ordered my seed. I just need to know how many bags I got to order. So we've gotten 14, 21. Anybody else? Just take a guess. 16. Okay. Thanks, Brian. Before we kind of get into the data, I would like to say I am talking exclusively plant populations here. Plant populations. There's a difference between seeding rate and plant populations, and we'll talk about that here in a little bit. So the biggest thing I can tell you how to manage your fields and manage your system is on plant populations, okay, because we can shift those things. Seeding rates can vary greatly, and there are several factors, including what planter you're doing or you're using, the conditions you're planting in. Everything can vary how effective that seeding rate is. What we're talking about 100% is plant populations. So we'll kind of go with that. Okay, so this was our first year worth of data, a full season corn from 2020, and this is kind of what we see. And this is in bushels, so we got bushels per acre. Sorry for the pounds, but I changed it for bushels per acre, plant populations, and then what I did this percent is I took a trial average, and then each plant population has a percent of trial average. So of course, if we're over 100, that means it yielded over trial average, and if we're under 100, it means it yielded under trial average. So we ranged from about 8,000 all the way to 28,000 plant populations, and what we see is we get this very gradual and then a sharp peak to about 18,000, and then we kind of trail off this year going anywhere above 18,000. If you look at significance, this is kind of where we draw the line. Is that none of these are significantly different from themselves, but they are significantly higher than our lower plant populations, okay? So we do have a threshold to where we break and we go to where we do get too low in our plant populations. So this was just 2020. 2021, we wanted to see something, see it a little bit more. And what we saw is same general trend. We got a peak right there at 18,000, got 124% of trial average, but unlike the previous year, we dropped pretty substantially when we got up to higher plant populations, okay? Why? Who can remember about fall 2021? It's a little bit dry in August, September, wasn't it? And so what did we talk about on required vegetation? When we have 28,000 and we have a good spring, we had a lot of vegetation out there that we had to manage. When mid-July hit and it stopped raining, and then August hit and it still wasn't raining, and we didn't cut until the 1st September, then we had to sustain a month and a half with very low soil moisture, very low rainfall, these big, massive plants at 28,000 plants per acre. okay? So there is these systems to where we can decrease quite substantially, but then you go back to 2021, had a nice year, nice fall, was fairly flat. So we could manage those higher populations, but the risk is definitely there. So then the question became, why was that there? Why are we seeing these slants on either side of the 18,000? The biggest thing here is that we had a significant decline in number of kernels per acre when we got lower. So basically, we didn't produce enough tillers, we didn't produce enough secondary cobs to make up for the fact that we just didn't have enough plants out there. We physically did not have enough plants out there. However, when we look at the 2021 particularly, what we ended up seeing is our seed depth and our density. We got really, really small kernels then at that year when we got a little bit higher. So while we had enough kernels, they looked like great ears. When you shelled them, there wasn't a lot there. When I used to work in Louisiana, we used to call those really light corn Midwest corn because they were there, they had size, they just didn't have the density to them. And that's kind of where we kind of fell off the back end, especially in a year like 2021 where we turned off hot and dry during that last quarter of grain fill. That's kind of a big issue for us. So it's not only about plant populations though, right? If I were to convince you, if you were to say, no, I like to plant 23,000 plants per acre, or I want 23,000 plants per acre out there, if you go lower, what are your main concerns? Most of the time, it's weed management. If I go lower plants, I'm gonna have more gaps. If I have more gaps, I have potentially more weeds. I could potentially spend more money on herbicides, right? Well, we took a look at that, and then I want to get into our weed management. So this is canopy coverage. So this is with Canopeo, taken at 3 different growth stages, V2, V5, V9. By about V9, what I'd like to see is the canopy closed, and that's where we kind of lose some of our herbicides because, you know, for all intents and purposes, it gets a little hard to get over the crop canopy when we get up to V12 and beyond, unless you got some specialized equipment. What I'd like to see is about 80% canopy closure. 80% canopy closure means that there's still a little bit of gaps in there, but we've closed a bulk majority of the canopy. What we saw is our higher rates, 23 and 28,000, were at well over 90, or right at 90% canopy closure, so we did well at closing the canopy. Our 18,000, which is where we optimized yield, was over that 80,000. We were was about that 85% canopy closure. So for all intents and purposes, even going down to that 18,000, we were able to close the canopy quite effectively fairly early in the year. If we were to go down, Bryan, to maybe some of these lower rates, we did have an issue closing canopy. It was one of those things where we maybe would have a little bit more gaps in the canopy, maybe a little bit more weeds that we'd have to manage for it. We look at nitrogen. Overall, for full season, this was our response. If you're a soil fertilist and you see this is one thing you don't want to see at the end of the season. Why? Because I want to see a plateau. I want to see to where it sharply grades off. That way I actually know where that optimum nitrogen rate was. But we went all the way, so we had 50, 75, 100, and 150 pounds of N applied. We really didn't see a plateau on it. And we basically were linear all the way through the 150 pound rate. This is across seeding, or this is across plant populations. When we look at them in the individual plant populations, really didn't see any variation in plant populations of how it impacted nitrogen rate. We continued to see almost a linear trend across the board in different plant populations. Why? What is our nitrogen rate recommendation based on? Is it based on plants? Yeah, it's based on yield potential. So if we have the same yield potential, it has the same nitrogen rate recommendation, okay? So when we're looking at this, if we have the same yield potential, we go out there and we say 130 bushels per acre is kind of where we're shooting for. That's what we're gonna get. That's kind of dictates our nitrogen rate. If we can get that with 18,000, still the same nitrogen rate. If we have to do 24 with it, still the same nitrogen rate. It's there because the yield potential is there, okay? So what does all this mean? When we talk about our full season production system, so we're sitting at full season right now, we're about to go into our other system. Semi-arid conditions, can populations be lowered? To an effect, I think in our corn recommendations, I think 23 for that Lahoma area was where our target plant populations have been historically. I think we can go down a little bit lower. How low? I'm not sure. There's been some things on Twitter. You see a lot of our growers in the state of Oklahoma being quite successful at 14. You know, we didn't quite get there. We weren't as successful as they have been at 14,000, but I'm pretty confident in saying that we can go down in certain yield environments. Remember, this is certain yield environments. When you're looking at 200 bushel potential corn, this might not be the system for you. But if we're at 150, 125, maybe 100 bushel yield potential on dryland corn, going down in your plant populations might be there. But there is a too low. You can fall off that cliff and go to where your yield does become limited. What about stability? Remember, we weren't thinking about higher yield. We were wanting better stability. We actually didn't see that. That 23,000, which was where we saw was our shooting point for our current recommendation, didn't have more variability than our 18,000, which was our optimum plant population. So even going down, we didn't gain stability. It just was because our old recommendation was just as stable as the 18. Now, if we go any higher, if we go towards our mid to upper 20s as far as plant population, we did see quite a bit of variability to that, but we saw the same amount of variability as if we went lower. If you go down that slope, we saw a high degree of variability with that as well. So there is kind of that sweet spot right in between that you have to kind of make sure that you're in. The biggest thing that I will say, if you do think about going down to lower populations, everything else has to be done really, really meticulously. Because you're already stressing that corn system out enough, we have to make sure that we got good singulation. We have to make sure we're not hill dropping that corn seed. We have to make sure that our plant populations, our seeding rate, our fertility, our weed management, everything else, our house is in line otherwise, and we can see if we can cut that seeding rate down a little bit and see if we can be quite effective towards it. Okay, so when we do the next one, the biggest thing, and I will say the best way to overcome heat is to just not plant a crop when it's hot, right? Easy. Any questions? I mean, that's kind of the whole purpose of looking at this double crop. And then whenever you look, you know, I talk about double crop systems a lot when we go to national meetings, and everybody's like, well, double crop's just an insurance crop. It's not. It actually has the potential to be a very decent system and potentially one that's got a lot of potential here in the state, especially if you have a year that has the right conditions. It's not the prettiest thing you can see. Sometimes it can be quite cross on being there. It's short corn. You will get short. It will be, Bryan, what do you say about that tall is typically what you can see. You're not going to see these mountain corns. You're not going to see all that. It will be short. It won't be the most charismatic for taking pictures, especially if we have an October 10th ice storm. You know, one of those kind of things can be an issue. But for a yield potential and everything, it does have some legs to it. So what we're trying to do is mismatching our critical growth periods. If you kind of take a look at it, and we'll do this exercise here in a little bit, what you're trying to do is move anthesis to grain fill, that most critical point for moisture accumulation. You're trying to move it outside of July. That's what you want to do. We don't want July, we don't want the first part of August to be anthesis through grain fill. We don't want any part of that process to be during that, okay? So what we are doing is we're shifting it later. Double crop inherently has risks. Corn probably has it at a much higher level than any of our other double crop. And we'll talk about why here in a slide or two, but there is risk. It always is a risk reward system. Probably is a lot higher one for this corn, and it is a much shorter season crop and a shorter statute crop. Okay, so I think this is the next slide. Apologize if it's not. So if I were to say that I recommend 115-day corn for full season, what do you think maturity corn for double crop? 118? 115? Is that it? Man, you guys are good. Well, so that's kind of been one of our things. When you talk to some people, they say, well, let's go down to a 90-day corn, right? That's not kind of what we're wanting to do. And if we take a look at planting dates, so using Mesonet, and thank you, Wes, for having that system up and going, taking a look at a long season hybrid, and then taking a look at a 90-day hybrid. So we did this on a 115-day hybrid. I think we used 2,600 growing degree day accumulations to do this for our long season. Looking at a 90-day hybrid, I think we used 18,000 growing degree day accumulation to get that 90-day hybrid. So if we were to plant April 1st, so kind of around what you would think on a full season corn production, north central Oklahoma, we'd be hitting VT on average about June 23rd. We'd go to R6, so getting to that maturity about the first part of August. Now, what is one thing I said we didn't want to do? Anthesis grain fill during which month? July. Okay? So this is what we're trying to escape in some of those regions. So June 15th, this is when we would typically say that double crop gets planted, right? Our soybean systems, our grain sorghum, something like that's June 15th. If we do that with a longer season, we are shifting that down to mid-July before we go VT into September, but we are still catching a good amount of July and all of the first part of August in that system. Not a good thing. Let's shift to July planting, right? We're crazy. I mean, this system came from Bryan, so we all know me and him are having some crazy conversations. But we don't VT, we don't go tasseling until the 18th of August. And we hopefully finish by the 10th of October. That looks pretty good. That's where we want to shoot for. What we don't want to do is shift over to a 90-day hybrid and go down here. We're going to maturity August 7th. That didn't help us at all. And if we plant July, we went maturity is September 15th. Now that does escape us some of that critical period, but we're still in that same period. What you want to do is go the same maturity or a little bit longer. We actually used a 119-day hybrid in this study. 119-day hybrid, so the same or a little bit longer. Planted, we always go the first rain after July 4th. Okay? By about July 25th, I call off the dogs and we don't plant it this year. Now, some folks do it a little bit later and have had success, but that just kind of gets to a high risk scenario for me. But if I'm recommending July 4th, first rain, if you get a rain July 3rd, July 4th, you're planting. Okay, but it's that first rain after July 4th that you can go in and be successful at getting good soil moisture. Okay, so this is what we see. Plant populations. Do they shift? No. They had the same setup as what we had on full season. Actually a little more pronounced, okay? And that's different because in like a soybean system or a sorghum system, what do we typically do with plant populations on double crop? We jack them up. 10 to 20% is what we recommend. It's not what we're seeing on corn. We're just not seeing it. Still, decent amount on 23, highest on 18. On either side, you fall off quite a bit. Okay, so kind of shooting for that same plant populations on corn. We look at nitrogen rate. The question then becomes on, do you increase nitrogen rate at all? Would you? Well, so this is all of the data all together. So when we take a look at this, the big numbers or the big letters, or if you were comparing at like N rates, so across those plant populations, the small letters are looking at a singular plant population and where that variability exists. So this is all that data, but I wanted to show it into a little bit different form. And this is our plant populations and our N rate along here, corn yield on the bushels. This is where we are. We're at a break point, depending on your plant population, between 75 and 100 pounds of nitrogen per acre. What was it on the full season? Okay, so we decreased where we saw our in response. Okay, so we look at this, 118 is our optimum, right about here, that's about 150 bushel corn. If you guys were to do the math, remember CCA, so we can do these fertility math in our head, right? So 115 bushel corn, what would be your optimum in rate? Huh? 115, Brian? 115 to 130, 40, something like that. It's not where we got. It's not even close. Now, the question is why. Me and Brian racked our heads about this yesterday. There could be a lot of things. We took soil samples on this, and based on our soil sample for this, we had very low N rate. But when did we take our soil sample? We took that back in April. So we could get a significant amount of mineralization you don't typically see in your full season by the time July hits. The other thing is if you look at the amount, the nitrogen percent of this corn and how much nitrogen we took up per bushel we produced was a lot lower than we would expect. So I think there might be two things, and it might be a combination of these. One, we have a lot more mineralization until we get here. The other thing is I don't think we have enough time to take up. This is short. This is short. We plant mid-July and we harvest the first part of August, middle of August. Okay? 3-month corn. That's all we're at. That's kind of where we get to. Okay? So this could be a very good reflection of a couple of things, but one, if you're going to do this, maybe take soil samples a little bit later. You have about a month typically between the time you harvest corn or the wheat and the time you plant corn. Be a great time to take a soil sample. The other thing is if you're going after a wheat crop, it might be one of those things that you might need to cut that rate down a little bit. But test. Just do your testing, because mineralization or the fact that this is a shorter crop, less biomass, less demand, could be one of those things that are getting there. We look at, and this is kind of where I want to go, seeding rate versus planting population or plant population. So this is across a couple different trials. This is not necessarily this trial we've been talking about full season and double crop corn systems and what our germination is. Basically, indifferent of what our seeding rate was, we got about the same germination percent. So it's not like we planted 8,000 and got a lot less or a lot more germination. We got about the same amount of germination. But the big thing is that we got about 90% germination full season. We're getting about 77% germination double crop. Think, you're planting in July. It is not friendly conditions, okay? So while plant population didn't change, what is your seeding rate going to do? Yeah, your seeding rate's going to increase, but that's because your germination rate decreased, okay? So your seeding rate is different from your plant population. You're still shooting for about the same plant population, but your seeding rate, because of the conditions you experience, are going to be a little bit higher. So I kind of wanted to do a little bit of an economic, kind of looking at something. When you take a look at can we decrease our plant population a little bit? When we take a look at our full season, it is one of those things that if we plan a little bit higher, our risk or our penalty for planting higher than optimum is a lot lower. When we go double crop, our penalty for higher planting is a lot higher. Okay? So we need to make sure that we have a really good idea of our optimum plant populations for that double crop. Because if we go too high, it's one of those things that it will get you a lot earlier and a lot faster. And we see down here, if we go too high, this was near that 28,000. We're almost at 80% of optimum potential economic return. So we're losing quite a bit of potential funding if we pay more for that seed and then also get lower yields because of it. So to kind of summarize before Bryan gets up here, corn does have the ability to flex, so let it flex. Like Bryan talked about, we have some really good flexing corn. If you get a good flexing corn and you want to attempt those low populations, we have all the data to support that it's within the realm of possibility. It's not going to hurt you. There is the too low. If you're at 23 right now and looking at Twitter and they're doing it at 13, I don't know if I'd go that low. But try shifting it down a little bit, especially in these really dry conditions. Your yield potential is around 100. 125, 130 has some potential to be able to go there. It really is dependent on that yield environment and the conditions. Double crop corn, should everybody plant it? I don't think it'll fit everywhere. But if you have really good systems, you have a really good field, nice residue. You don't want to go into beans. You get a nice rainfall in July. It's one of those things that it is a potential to kind of go in and throw some corn in and get some late planted corn, late harvested corn. But remember, it's not like every other double crop. We can't treat it like it's just a grain sorghum double crop. It's different than grain sorghum. And there are risk scenarios with it. We see that in 2020, we had standing corn at about 90% milk line when we got a major freeze. And that is a potential risk. Of course, that same year, our soybeans died that were double crop anyway. So there is a risk. Double crop inherently comes with risk, Corn has that extra added risk because we are planting it in July, not in June. So there is a risk at the beginning and the end of the season. You're just trading off for a middle season risk for potential risks on either side. Okay? Questions? Yes, sir.
Lower populations are clear across the deal. Did you take pollination count for your lower yields on your lower populations versus your higher populations?
Like,
Sometimes we have 40-mile-an-hour wind and more than 100-degree temperatures. We're going to sell that.
yeah, so we took, so for that study, we took corn. So talking about did we get changes in pollination potential because we had the lower, yeah. So on that study, we didn't do that exactly, but what we did is we took subsamples of corn and we did number of rows and row lengths, and we didn't have a discernible, hey, this has a significantly lower pollination potential. They were all pretty full. There was no like identifiable thing that there was one area that had lower pollination than any other treatment. Didn't really see that. Okay.
And the presentation you've been waiting for, not because of the title of the person, but because it's last and you go home. So thank you for the hardcore that stuck it out. And I know most of you, it's because you need that CCA nutrient management credit. So I get it and I understand it and I appreciate it. So going through what I was going to talk about, had a lot of different ideas, trying to come up with something that fit the topic. By the way, Josh, thanks. Go give them CCA exam kids hell. All right, so kind of I was sitting around, so we started this on Thursday, so Wednesday night I was sitting around kind of late, and I said, you know what, maybe I figured out what I'm going to talk about. Because I had an idea that I was going to talk about one thing, and then I saw some conversations that made me think I'd talk about another thing, and so I thought I'd let Twitter decide, and it gave me no help whatsoever because they said it was equal. So within 3 people, I either needed to talk about biologicals or UAN versus urea and no-till. And so the consensus was, let's just do them both. And so we're going to kind of run through in short order. And Dave, I will stay in this area. Okay? I'm well aware of my running room. So kind of go through both of them, what we've got data-wise, what we don't have data-wise. And so the biologicals, kind of give you what I have data-wise, explain to me, I'll explain to you why I don't know if that means anything, and then actually kind of get in a conversation about biologicals. And I will preface this, I'm talking about biologicals, not enzymes, and not acids. Okay? So a lot of the times when I say I'm talking about a biological or a microbial, people say, well, tell me about humic acid. No, I'm talking about a microbe, a living organism that's being put into play in the system, not a humic acid, not a fulvic acid, not an enzyme, not a growth regulator, not those things. Okay? So we're getting into that. And then we'll talk about the UAN versus urea no-till, which honestly has challenged me in what I wanted to see. So part of it I expected, other parts were like a little interesting. So first, I've been playing with bugs in a jug since I started in Masters. And literally the first product I had was bug in a jug because it was a milk carton. It was a milk jug that had been grown in a stock tank. And there were water bugs swimming around in it that, clogged up the filters. That was the first bug in a jug, and that's why I can literally say bugs in jugs, because I sprayed bugs in a jug. It's changed. The marketplace has changed. You all know that. And right now, I've got access to some pretty good folks in industry, and I'm not talking local, I'm talking national, international industry. The board members are going to tell every agronomist is if we don't have a biological in our portfolio, find one. We don't care. That is the answer. We don't care what it does. We don't care what it is. We need a biological in our portfolio or else. And a couple of them have been told figure it out or be fired. Flat out. Find something in our portfolio to get it offered or you won't have a job in 6 months. So the big dogs are in a race war. There's companies being tested, companies being bought, companies being traded. Everybody is trying to have something in their portfolio, and you all know what I'm talking about, right? And it used to be 20 years ago, my CCAs, my farmers that are around 20 years ago, if somebody came to you with microbial, was it going to be a Monsanto, a Corteva, a Bayer, a Syngenta, a Dow? Or was it going to be a mom and pop fly-by-night small program for the most part, right? Now it's big names. And most of y'all in here have a product in your portfolio, right? Or out of your you've got access to something you can sell that's a bug in a jug, one way or the other. So sorghum checkoff started up, helped me out. I got in a project last year that was so-so, got in a project this year, so this started 2023. My approach was this. None of these companies gave me any money. Okay, this is all funded by the sorghum checkoff, and the extra funds came from fertilizer checkoff, so this is not corporate funded, just so y'all know. My approach is I want to have a nitrogen response curve and then apply all the products at a reduced rate, a rate below optimum, and see if we can say, okay, we raise this much yield, that's equivalent to this much nitrogen. Does that make sense? So I'm not applying full rate, I'm applying sub-rate to the plots, and I'm trying all these products. We've got in furrows, we got seed treats, we got over to the top, we got soil applied, we got soil sweetener, soil conditioner, we got all the good stuff. We were like a freaking pit car crew, and some of y'all saw me on NASCAR. This is something the companies don't even get, and it kind of ticks me off about the lack of knowledge by the scientists that are peddling these things in the corporate industry. I go through what my protocol is, and for every one of these treatments in the 2x2 or the in furrow, we run a product, we push it via CO2, so it's being pushed through our planters through CO2, and then we do what? Then we dump it, we rinse it with water, then rinse it with alcohol, then rinse it with water, then put a new product back. No cross-contamination. Seed treat, we're wiping down between. Talked to one company that we're doing 18 different seed treats. And I was like, wiping down, why would you wipe down the seed box between seed treats? Well, if every seed treatment's a different biological, what's the chance of there being cross-contamination if I just keep dumping it down the same freaking tube? That's a corporate scientist saying, why would you do that? It bothers me a little bit on that side, to be honest. Got another company that said, hey, you need 100 foot between plots. You got a 4-row plot, you need 100 foot between your next plot. By the way, that is hard to do on a small scale level if I got 100 foot distance between. And then a week later, their marketing group came out with the side-by-side photos. Like, look what our product does. Meaning a row next to a row. Don't tell me I need a 100-foot buffer, and then your marketing group shows me one row and the next row. So it's still a wild, wild west. And I mean it's wild, wild west because there are millions and billions of dollars dumped every single year into finding this. And I'm not saying they won't work, okay? Cotton Incorporated. So Checkoff said, hey, we got this. I asked how many of these companies their product could be applied on cotton. And we didn't do in furrow. Because how many row spacings do we have on cotton in Oklahoma? Way too many. That's the answer. My 30-row planter can go all over the place, and I can do my in furrow really easily. But we start going to, okay, I'm on 30s, I'm on 32s, I'm on 34s, 36s, and 40s. There ain't a planter around that I can go to a station that can do what I need to do that effectively. So we went over the top, all those, Cotton Incorporated, I kind of leveraged them. Like, hey, the Checkoff is doing this. What if the Incorporated kind of comes back and does something cotton-wise? So we've got that. You see what we got. Implemented it this summer. You already know the story now, right? I mean, we put it in the ground in 2022. So such a special year. You see our planting dates. So this is our sorghum stuff. I will note that we planted at Chickasha, what was it, March, April? Right in here. And it rained 6 inches in Chickasha. Flooded out our first rep. Everything else was beautiful, and then it didn't rain again. Right? So we had one rain and then no more rains. So we lost our first rep at Chickasha, but every other plant was up, and I was not about to kill what I had because it had already started to get hot and dry. So I was like, we're going to run with what we got. And then we go in our other two locations, Lake Carl, Blackwell, and Perkins. Perkins is a loamy sand. Lake Carl, Blackwell is kind of silt loam. Lake Carl, Blackwell, we had overhead irrigation once the lake got enough water in July and then ran back out by August. But we were irrigating 1.5 inches every week in 2 passes, 3/4 of an inch until from the day we had water to the day we lost water because it's coming off the lake as an inlet. Put on 9 inches of rain. And then at Perkins, and this is why I tell the companies, I tried my best to keep the stuff alive. The crew went out with tanks and we had polyline and drip on harvest rows, turned drip tape upside down, and we were running a crew 6 days a week, hauling out 4,000 gallons of water every day, 6 days a week in a 3-day rotation to keep 3 of my 8 sorghum trials alive. Alive. This was not irrigated. I don't even think it's supplemental. Lofton had a term for it. It was watered or something like that. But we did keep them alive. The year before I cut 120 bushels Perkins, I'm going to tell you it wasn't 120 bushel this year. So what we learned, and while I'm not going to go into the data, this data I do a couple ways. I do just looking for treatment differences, and then I compare everything back to the 60. So the sorghum, every plot had at least 60 pounds, and then I had the end rate curve. So every individual treatment, I don't compare one company versus another. The comparison is that treatment versus the 60-pound check. That is the only comparison I ever did. Oh, by the way, we ran minerals. So we took the grain, we harvested the grain, we ground the grain, and every mineral, nitrogen, phosphorus, potassium, sulfur, manganese, copper, boron, all those we analyzed. All locations, all things we ever measured, not one treatment was different than the 60-pound pre-plant. The 60 was no different than the 80, no different than the 100, no different than the 120, and none of the other treatments were different than 60. So what did we have? We had a flat board. We have some trends, yes. I'm not going to run on a trend. I mean, so we could pull this one out right here, right in the middle. 60, 80, 100, and then 120 drops. That right there tells me I've got variability and I just happen to see a stair step in a couple because 120 shouldn't be that far below 60. Just highly variable. Stress, how many of y'all saw stuff pop out in your fields because of the drought that you hadn't seen before? There's just a lot of things that we couldn't fight in this one. So that's the answer on that one. My sorghum, this is all run, no significant difference. I got to tell them that. We tried our best, but we saw nothing. Cotton, we just got that done. So this is a generated turnout, so we don't have turnout yet. We have seed cotton and we have our normal efficiencies at the 2 locations. By the way, surprisingly great yields, not at Fort Cobb. Fort Cobb's always great yield. The Oprek location, which is right here, the 2,000 pound was a lot better than I thought. Who knows what happened at Altus? Jimmy Wayne, can you guess what my yield at Altus was? Insurance out at 4 pounds. So that location was out. So we go through here. We ran stats. I don't think you need to look on here and see that stats needed to be ran. All right? Fort Cobb, I love Fort Cobb. Bobby is amazing down there, but they're in a peanut cotton rotation with a whole lot of in the cotton years. We don't get a huge in response in cotton at Fort Cobb on a regular basis. And look at that. We're talking almost 3,000 pound cotton. That's lint, not seed cotton. 3,000 pounds of lint with no response to nitrogen. There is maybe a trend with neutrino, but we're not, I need more years, right? So I'm going to go back, I'm going to go to the company and say, hey, let's keep, or not the company, I'm going to go back to Sorghum Checkoff, back to the Coppin Incorporated, say, hey, let us keep going. I'm going to ask the companies to again submit. By the way, I followed the labels to the T in every way possible. If the label said it, that's what I did to the upper levels, the most rate, the best flow, the recommendation. And if I didn't understand the label, I contacted whoever was my contact, said, tell me the best case scenario for application for each one. So I want to make sure. So with that, I want to have a little story time with y'all because you know I like to talk stories, like to talk theory. This is my understanding of what we're doing with biologicals, and I just want to share with you my challenges with some of these in our climate. Remember, you've heard me talk about this before. A lot of these may or may not be derived from northern territories. Minnesota, Michigan, dark, black soils, 4-6% organic, not all of them, but some. Several of them have a tendency in Corn Belt region specifically. So one of the first ones you see, if it starts talking about releasing lots of nutrients, not just one or two nutrients, but releasing lots of nutrients, we're talking about a biological that's more than likely built to break down organic matter. That's its sole purpose, is to break down organic matter. If I'm in northern Minnesota and it's cold as hell when I plant, it's going to get cold really quick at the winter, I want to break down that 6% organic matter to release nutrients. If I'm in Kingfisher on a piece of ground that's been tilled for the last 100 years, I don't need help breaking down organic matter. What's there will be gone. Huh? Probably already is, even without rain. So the organic matter decomposers and me in this country have a little bit of, I'm a little bit unsure of the purpose of decomposing organic matter at a faster rate than our environment can already do, which is pretty fast, right? I mean, there might be conditions, heavily irrigated corn, if you want to break down the residue, fine. It's more of a residue decomposition than a nutrient availability to me at that point. So that's that. The N2 fixtures. So John's back there. I've known John. So this is the nitrogen fixtures. We have this conversation on a regular basis. I'm not convinced that we can guarantee a certain pounds of nitrogen, John. I'm just going to say that. Not convinced that any product that is biological can guarantee me a certain pounds of nitrogen in any environment. We might be able to be that. I'm not saying we don't. We very well could do that. But biology and environment, especially our environment, makes me question that. But here's a big question. If you're applying one of these nitrogen fixtures, one of these biologicals that is creating nitrogen, are you reducing your nitrogen rate? And if you tell me no, then the only reason in hell that you're applying that is you're assuming you're under-fertilizing already. You understand what I'm saying? If you're applying something to make more nitrogen and you do not lower your nitrogen rate, that tells me you're assuming you're not applying enough nitrogen. Or you're under-fertilizing on the regular. Otherwise, why are you putting on more nitrogen if you don't think you've got enough? So, I want to tell you, if you're going to use one of these, we should consider your nitrogen management strategy and maybe reduce it. If you want an ROI on a nitrogen fixer, figure out how much nitrogen it's going to fix and adjust your end game. And some of these products will sell, you can drop your rate by 20 pounds of N. You go to the panhandle and drop a corn farmer by 20 pounds of N that's been on 300 pounds a year for the last 20 years growing 270 bushel. You think you can pull that off, Eli? I think I could drop it by 20 pounds without a biological. Huh? It depends. So the standard rate, drop it by 20, drop it by 25. Theoretically, I don't like that because it's a biological. It shouldn't be that guaranteed amount, and that number tends to be what I could flirt with by just pulling the average person back and not changing a whole lot of input. It's a safe rate that we can get away with in many of the situations. That's the N2 fixtures. I really think if you're going to implement it, you need to change your nitrogen management strategy from your traditional if you want an ROI. If you're going to pay for it, you better find a way to pay for it. Or I do get the guys in the Corn Belt that have a lot of nitrogen loss. They'll put it on in fields that have heavy nitrogen losses or likely of a lot of denitrification, meaning there's a lot of water standing throughout the year, so they might have areas that have denitrification. How many of y'all have had denitrification because of water standing in the last 3 years? Bryan. This last year you had denitrification? Okay. We can have that, but it's not as common, right? And where it happens about every year. We can manage around that, but it's just one of those things to keep in mind. The symbiotics is another one. That's an intriguing one to me. We're putting a biology in the ground that's going to create a relationship with the plants and basically make a bigger root that accesses more moisture, more nutrients, the symbiotes. It is intriguing. I think there's potential, but the soil microbiologists that I work with, this scares me. Go listen to the Red Dirt Agronomy podcast when we talked to Karen Hickman about invasive species and what does it take for an invasive species plant-wise to be invasive, something that is competitive against the natives and reproduces well. It worries me a little bit about putting foreign microbes into our soils, and foreign can even be the difference between Altus and Stillwater. The microbiology in Altus is not the same that's in Stillwater. That is foreign to the Stillwater soil. I'm not saying it's bad. I'm just saying it's been said to me before, and I mentioned it a couple of you in the past. Do we know if we're going to put the next kudzu below ground? That thought has never left my mind when we start talking about introducing foreign biology into our soils. And I want to tell you what, my understanding from our microbiologist is our bugs are pretty freaking tough in Oklahoma. Think about what our soils do versus a northern corn belt soil. Hot, cold, dry, wet, all this stuff. They're just kind of living luxury in a 6% organic matter that freezes 3 months out of the year, and they come out, they have organic matter, and they go back in. Our natives are they're pretty tough. They're pretty tough, so there's that. And then the final is nutrient mineralizers, and I have already talked to a bunch of industry. There are products out or coming out that have great capability biology-wise, and this might be on the enzymatic a little bit, to mineralize things like phosphorus that's in labile to near fixed points. So it's not the immediately labile, they're taking the labile phosphorus, they're near labile to fixed phosphorus and making it mineralized and more plant available. I think that has great potential, especially on ground that has had historic application of animal manures, and you have a history of applying phosphorus and it's in a labile to fixed form above the native background. And I don't mean to pick on kingfisher, but it just comes to mind. I don't want to take this stuff out to a field in kingfisher that's had urea or anhydrous for the last 80 years and never a drop of DAP or MAP. You're then taking phosphorus from a system that's been giving up phosphorus for a long time. So again, I think it has a lot of benefit in regions that have been heavily fertilized or have had a lot of manures applied. It makes a lot of sense to have something help break that out. But I'm scared that some of our cheap farmers, I know none of you are our cheap farmers, but some of our cheaper farmers or low input folks are going to see this and say, you know what, I don't have to fly for, they've been telling me to put down phosphorus for years, I'm not going to have to do it, I'll just use this microbe. And that worries me a little bit on the system. It's like banding DAP with your seed instead of liming. We're just creating a bad system worse by band-aiding it. And so, like I said, I think there's great potential in that technology. There's also potential in some regions that we can get hit. And unfortunately, that does fit some of our Oklahoma production region that I could see it falling in kind of in a rough spot. Does that make sense?
So if you're going to do both, because you just said you're going to shoot yourself on the Band-Aid, use that mineralizer, you're going to, the aluminum wouldn't get tied up in?
No, so I don't know the interaction of some of these products, and that's more on the chemical and enzyme side where we're using enzymes to prevent tie-up of phosphorus and keeping it more plant available. I do not know, that's a good question, Mike, I do not know what that means as far as aluminum tie-up, because that would say that if I'm using phosphorus to bind aluminum and I'm putting something in there to keep phosphorus more available, maybe my aluminum toxicity is not masked as well if I had straight phos. Something we can look at. Huh? Yeah. So that's what we're pushing hard. I'm trying to understand the application of these biologics in our soil system. I have no doubt that many of them, some of them, something works out there. My concern more is finding out how it works in our system, how it can be applied in an economical way, positively, and understanding those. That's why I want my hands on these things. I have no problem testing products because I want hands on. I want to know how they handle. I want to know how they react in the field, and I want to see their impact on plants. And so I know we've got stuff out there. There's too much money being put into these things not to be getting some good wins. But a lot of the research is not done in the Central Plains. It's coming out of the Corn Belt. It's coming out of a soil system that is slightly different than Altus, Guymon, Kingfisher, Medford, Ottawa County, Miami. It's just, everybody's different. We all know that. It all depends, but there is my concern. So my hope is to understand these better and to put an ROI on them. I don't have data. That's all I got, so I want to share with that. Everybody good on that topic? Okay, so real quick, I'm going to go through this so I can let you all go because this has come up. I've been asked a lot about this coming recently, so I guess about 2 or 3 years ago we started this Source by Time project. And I know it's Coke, and I'm not getting any funding from Coke. Yeah, Coke sends me product, but really it was one of those things that came around planning time, and we had spot for a trial, and I had a bucket of Super U and a brand new jug of Anvols. Like, oh, let's just try this stuff, right? So some of the things you just do, you just have access to it. Kept it going. So we looked at Super Urea and UAN, Super U and Anvol at either early, so a winter application, an early spring application, or a joining application in wheat. Basically 3 different timings of nitrogen. So winter, spring green up, and a jointing timing. Super U is a coated urea. It's in MBBT with DCD, so you have the urease inhibitor and nitrification inhibitor. Anvol is basically doped up Agritane or Agritrade Plus. It's MBBT with the Duromide. The Duromide is advertised to make the MBT last longer, so you're basically increasing your half-life, where I'd say Agritane had a half-life about 7 days. They say this has a longer half-life. I don't have the data to say one way or the other. That's the marketing on it. So it's an MBBT. I understand that component. I understand MBBT and DCD. Worked with both of those products a lot. So you just using them as kind of a standard going out early. Note my rate, 60 pounds. Y'all should know by now when I do nitrogen fertilizer studies, I go low rate because at a high rate I don't see differences. I want a stressed rate where a couple pounds difference is a lot easier to tease out in my data than if I went out at 200 pounds of nitrogen, right? So I go at a low rate. Wheat, I run 60 pounds. Our applications November, January, March, and April. We'll go through a few sites quickly through here, what we see. This is Alva's site, so this was out on Kent Martin's place. This was heavy, heavy residue. In fact, I want to say we were wheat falling, sorghum falling, wheat, sorghum, wheat, basically constant, and all that residue was there. We were massive thatch this year, and so you see that winter application. By the way, UAN is streamed on. This is not flat fan, it's T-Jet SJ3 streamer nozzles all the time versus urea broadcast. Fall, so this is also 20. Do you remember what the fall/winter of 20 was like? Dry. How about the fall/winter of 21? Dry, right? So all these years, this is all no-till, and effectively our December rainfall in those years were very little to none, okay? Dry wheat, dry residue, a liquid fertilizer that sits there from November, December, and January without ever getting washed off. It wasn't shocking to see that urea or a dry fertilizer made a benefit there. And I'm going to tell you, if that ground is dry and the residue is dry, I'm going to go with dry fertilizer all day long because that dry fertilizer has the ability to work itself into the residue and closer to the ground. The liquid's going to hit that residue, and if your humidity is 40% and your wind's 30 miles per hour, it's not going to go down anywhere. It's going to stay on that residue until the next rain, and then it's going to start breaking down, and it's not going to be plant available. So we see consistently, this is big. I mean, we go 35 bushel to 50 bushel liquid to dry. Did see a little bit of the Super U wind. This was a deep sandy soil, so maybe some of that nitrification inhibitor came in play. We did have a nice response to nitrogen. That's the unfertilized check. March application, good timely rains. Everything pans out. Really no application difference between any of these. Super U, urea, UAN, streamed on, UAN plus Anvol. No statistical difference between those others. March, we had good timely rains, good weather, and that's what you expect. You put on Agritane or something and it rains the next day, half an inch, you really didn't need Agritane. I've been telling you that for a long time now, I'm pretty sure, right? So good timely rains. In the April, about the same thing. That area, we got good rains. This was without phosphorus. If this site, we had a phosphorus study next to this, and we're cutting 95 bushel wheat near Alva in the center. It's actually near Hopeton. So if you all know where Hopeton is, or anybody? You wouldn't expect 95 bushel wheat on a daily out there. So it tells you we had good rainfalls in that spring, right? So good rainfalls, not much difference. Dry versus liquid early. We go, this is Caldwell, so this is up in Caldwell, Kansas. Same thing, heavy. This was a lot lighter residue, but it still had some wheat residue, wheat on wheat. We have a little bit of wind on our dry versus our liquid. No real difference in any of our stabilizers. We do have numeric differences, not that. A huge win on urea. Why this? We went about a week or so without rain, and it was kind of dry when we put it out. This whole liquid sitting on residue without dry residue without rain for a week or so is starting to show its sign that it's liable to be tied up. I don't think it was lost, because urea would have been lost just like the UAN. It's got a lot of that. I think it's more of a tie-up. Late. This came in too late. In fact, we were about flag leaf when we finally got out there for that application, but no real differences in any of those. Moving through. Another location, November, dry residue. We do see the UAN with Anvol, not statistically different, did have some wind. Numerically overall, we have a little bit of a benefit on the dry. And so this was 3, so we're talking a November application. And then March, when it's raining nice and still water, everything works the same. Chickasha, I hate Chickasha for nitrogen studies. I can never get a nitrogen response. The check was 37 bushel and everything else was too, and that's probably 40 bushel below what it should have been. That's how Chickasha works for me. It's either 90 bushel with no response or 30 bushel with no response, and I have nothing in between. Last location, or second to last, again, we have wind on the dries, liquids down low. We have dries again in March, a little bit of dry in February, just moving through so you guys see this. Not getting a lot of the stabilizer wind. We're seeing something weird about this. February application is kind of beating the urea, straight urea over everything else is kind of winning out on that February timing. Cooler, a little bit more intermittent rains coming out. A lot of these years, we weren't getting our first rain until February in 2021, if you all remember that. Those are all by site. I put it in and I grouped everything. And so the stats now are by timing. So I'm only looking at November, I'm only looking at January with these numbers. When we look at the fall applied, Super U and urea were both better than UAN. UAN with Anvol kicked up to be equal to urea. Statistically, numerically, we're getting really close to separating out those. I'd say after 6 site years, that's all of them. Even the non-responsive site is in there. We're getting pretty safe to say that if I'm going to do fall applied nitrogen and it's dry, stay the heck away from liquid. On no-till, again, no-till, heavy residue, all these locations. We go into spring, no difference. We go into March, we're seeing something here. So this is right here, this is UAN, a little bit lower than the rest of them, which is probably a combination. We got surface application, small particle, staying on the surface, a little more humidity, more likelihood to loss. And then we go back at the end of April and everything's about the same. My story, what should you do? You all know what you're supposed to do. It depends. Is it cold? Is it hot? Is it dry? Is it wet? Is it no-till? It goes back to, it should be, in theory, a site-specific method. Is there one perfect method? No. We see a lot less value for some of the stabilizers at different times of the years. I would have already gone in not expecting Super U to have a whole lot of value for springtime. It was going to be, if it was going to have a win, it was going to be a winter application, hoping that DCD held me on a little bit longer. I thought I'd get a little bit more from the urease inhibitors in the springtime. Saw some cases, but it really didn't pan out that much. We'll keep it going. We have 3 more sites this year. Also have done it, I was going to show you this. So this whole winter thing. So this was 2001. Basically all the years look the same. Around November it stopped raining and really didn't start raining again until February. That was about 2 years in a row we had that as our winter pattern. Just saying, we've done it in sorghum. We had 3 locations last year. There's no data to share. That's not one that we tried to save. So we're doing it. We're trying to keep this going. We have different timings, 30 days after plant and 60 days, or 21 days and 35 days after plant. Actually looking at early, cool, wetter, as we get more into the season, does that inhibitor source have a difference? And with that, that is what I have. I want to put an ad in before we go. We have Dave Deacon in the back, and I appreciate him. We do have, if all of you should know by now, there is a podcast. It's called Red Dirt Agronomy Podcast. It's myself, Jason Warren, and Josh Lofton. We do it together, and we yell at each other, make fun of each other, and we bring on a special guest. And sometimes we make fun of them, and sometimes we don't. They're a little long, but if you have a long tractor drive or a truck drive, I think they're kind of good. It's just a thing we do for fun. It really is just us having fun. I appreciate you all being here. I appreciate you all sticking it out. I know some of you really need that CCA credit, but I still appreciate you being here. Be sure to tell me all the bad and tell my boss all the good, okay? Find a way, tell them everything you like about it, but seriously, tell me, tell Lofton, tell whoever's around. We want to keep this thing going. I want to keep Winter Crop School something that is challenging and informative. That's why I don't bring up too much basic stuff in here. Y'all know that I don't like this to be basics. I want this to be, you are CCAs, you're D1s who have that background, and we want to push you whether you agree with it or not. And that's the purpose of this meeting for me. When I'm not doing it anymore, you can make the new person do whatever the hell you want them to. Guys, I appreciate it.